Yeah, so thank you for coming. Again, like if you already know me or have been to my talk or workshop, you know everything goes. So I'm very flexible here, especially for workshops. I want it to be more interactive. And if you have questions at any time, raise your hand. If you are here with me, I will come to you. Or if you have a question that you want to just like shout, and I can repeat for the remote audience. If you're remote, please use the Slido. We would have volunteers here to direct your questions, so hopefully we can still answer your questions. So I think for those of you who may tune in a bit late, unfortunately the projector is somehow not working. It's the first workshop, so we are kind of testing it right now. So, or maybe it's my computer that doesn't like it, I don't know. But anyway, I have put the workshop material link, so it's a GitHub repo, on the description of this session. So if you go to the conference schedule, click on this session, you should be able to see the link to the GitHub repo somewhere in the description, right? So before we start, before I let you start working, just a few explanation of why we are doing this, why we want to know about Polars plugin. So who has used some like custom function when they are processing a data frame? Yes. So the thing is, we use Polars. So how many of you use Polars? Yeah, so we use Polars because we love it being fast. It's written in Rust, by the way. We also need custom function because sometimes the default function provided by the framework, which is Polars, doesn't fit our needs because we may have some niche use case that like, I am manipulating the data in a way that nobody will ever do the same. So it's not useful for the Polars maintainers to include that. So you can write your own custom function. But the problem now we have is that if you're writing your custom function in Python and use a Lambda function or whatever apply to your Polars data frame, it may slow a little bit of it down because Python is slow. And also because like Polars need to do some conversion when it's changing the Rust thing into Python thing and the Python thing into Rust thing. So to avoid that, what we could do is to write the custom function as a Polar expression in Rust. So that's how the Polars plugin come in. It's like a very good tool that, if you are capable and comfortable writing in Rust, that would give you a way to hopefully get your custom function running with Polars faster. I have also included some pre-flight check and what you need to know before coming to the workshop and what you need to install before coming to the workshop. I hope most of you have Rust installed in your computer already. Like that's the first step. If you don't have Rust, if you can't compile Rust code, I'm afraid you may not be able to follow the material today. You may have to do that first. So, and then we would use Rust, also we would use PyO3, which I'll explain a little bit later what it is, to create something that can work in Python. And then we'll test it in Python. So we are using Python 3.13, kind of new, in the workshop. You can still, it should be compatible from 3.9 upwards. But if you see something weird, please let me know. I will come and have a look. Also, we use virtual environment, make your pick. I use UV now because, it's, again, like new and shiny and fast. I love it. So, yeah, so, again, make your choice, but something may be a little bit different from the instructions in the workshop. If you're using Windows, the lucky ones that are using Windows, lucky ones, you will have to install some extra stuff because, yeah, like you have to have some default like C++ build tool and some kind of like make sure the file works so you can compile your Rust code. Unfortunately, I am not a Windows user. I, graduated from Windows a long time ago. So I will try my best to help you, but not guarantee like that I can solve your problems. I'm not a Windows expert. Hopefully there's some Windows expert here that they can help you, hopefully. So also, because today we are writing Rust, we'll use PyO3. If you want to learn more about Rust and learn PyO3, I've also put down some resources there in the repo. You can go there and check it out. So today, you can just follow along. You don't necessarily need to be able to write Rust yourself, but in the long run, if you want to do something like customize your function, of course you have to learn Rust. So those are the materials for you. And then after that, again, like setup instructions, very simple, things that, create a virtual environment, install Maturin. Maturin is a tool that is in the PyO3 kind of ecosystem. So if you use PyO3, then you I think 99.9999% you use Maturin as well. Technically, you don't have to, but you would make your life much more difficult if you don't. So install Maturin. Maturin can be pip installed. Of course, Polars, because we want to test it out, so we'll use Polars to test it, of course. I've also marked down the versions that is assumed in this workshop here. Again, it could be compatible with other versions, but if there's something weird is going on, then maybe matching the versions could solve your problem. So. Unfortunately, again, I would love to do it together with you, but unfortunately, the screen is not working. So, yeah, I would just explain the first exercise, what we do. So I think before we jump on to write some Rust code and get excited about it, we would just look at how the workflow should work, because I know all of you are mostly Python developer or data scientist, or someone use Python a lot, but Rust may be a little bit, you're not so familiar with it. So how we got to do is, again, we would use Maturin a lot. So Maturin can also help you to start the project structure. It's a little bit unique because it's not like a standard Rust, even a standard Rust project. It needs to have some extra kind of configuration. So I think if you do start any PyO3 project, the best way to start is to do Maturin init. So if you type Maturin init, which is, again, if you're following along with your own, reading the material, you'll see that step one, start a project with build settings. So if you type Maturin init, you will see that a lot of files and, all these structures of the whole directory is setting up for you. We'll have to make some adjustment because the Maturin default is not designed to let you use it with Polars, right? So, so first of all is that we have to add something in your cargo.toml. So what cargo.toml is basically like your PyProject.toml, but for Rust. So. Yeah, so again, if you follow along, if you see the code there that I provided, you see we have to tell the project, basically Cargo and Maturin, that I am also including Polars in my project here because I'm building a Polar plugin. So Polars need to be included. PyO3 usually is already there because Maturin is designed for PyO3, so PyO3 will be there. Another thing we need is PyO3 Polars, so another dependency, PyO3 Polars, so that is letting you use some, basically it's letting you write these extensions because, okay, what is PyO3? PyO3 is, if you haven't heard about it, is a library that lets you compile your Rust code into a Python library. So the funny thing about this Polar extension is kind of like a Python library that is a third-party plugin for your Polars, right? So PyO3 Polars basically is doing similar thing as PyO3, but they added, so it's kind of like extra stuff that they provide us specifically if you're developing for Polars. So we need that in short. And then the last one is, I don't know how the community pronounce it, SERD30, I don't know. It's not even English, but yeah, we need that because we are using some functionality that it's provide. And I forgot what it is. I will tell you when I remember. Okay, so Also, so yes, questions?
So which material exactly do we need to follow along? Because
Okay. Right.
From this presentation, the website that describes it from the PyCon conference, there's some, I don't know, UV setup, Polars, Maturin, so where are the bottom?
Yeah. There is a link. I know it's not very obvious because I just added like now. So, so if you scroll down through all the instructions for setting it up.
Workshop materials. Thanks.
Yes, thank you.
Thank you.
Yeah, let me know. Like, I mean, like you were. I was like, oh, why don't you ask the question earlier? Because I feel so sad that you are like, oh, I'm so lost for, like 10 minutes, and I want to help you. Okay, so yeah, go to the link. It's just the README file that I'm talking about here. So now we are at step 2. Define. Oh no. Just above step 2, define expression logic in Rust. So we are talking about that section there. So so before the question, I was talking about those are the requirements, the requiring libraries for Rust. So that's on the Rust side. But we also need something on the Python side, right? Again, we're going to test out our project. When we build the extension, we'll test if it works with Polars correctly, like intended. So in your PyProject.toml, which is on the Python side of things, you have to also add the requirements there, Maturin, because again, like we are using Maturin a lot. Without Maturin, we can't do anything. And also Polars. Again, I have marked down the version. There's like some version requirement there. Is mainly because for older version of things, it may work a little bit differently, so I mark it there just in case. And then after that, like PyProject.toml, we also added one settings there. So it's like for Maturin, so that setting is mainly for Maturin. So we say that the module name is, so in the README, it says Polars plugin 101. Actually, it doesn't need to be that. It's just that, like, the name of your plugin. The important thing is _internal. It's internal because if you don't do it that way, Maturin will just build a library that you can just use it alone. But so this library that we are building is an extension, right? It's a Polars extension. So it need to work with Polars, and it need to do some kind of like, you will see in a bit later that like we need to do some kind of customization on the Python side to make sure that it works with Polars in Python. So that's why we mark it as internal. Maturin will still compile it, so it is something that have a Python interface. We can still use it in Python, but we'll make sure that it works with Polars in a bit in Python code. But don't worry too much about it. Just know that it's like something special for the Polars extension. So now, step 2, define expression logic in Rust. So this part is quite straightforward because it's just, if you have do PyO3 before, that should be not, should not be something new to you, except a little bit of things. But if you're new to Rust, welcome. I would, just quickly go over. So the keyword use is kind of like import in Python. You can, without that, the compiler will say that, oh, you haven't imported, you haven't, link it up. Like, why you're saying something that I don't understand? And then, function fn is like df in Python. And then, of course, there's all these curly brackets. So that's, syntactic is the syntax in Rust is different than Python, but it should be quite similar enough for you to understand what's going on. Also, you will see the mu and let a lot, again, very unique Rust things. It won't appear in Python. If you want to learn more, there are materials about PyO3 that you can learn about, or Rust that you can learn about. So the first, so again, like I won't go too deep into the Rust code, like what does it mean in Rust, because I have another workshop that's like, we would dive deeper into like writing, PyO3 and Rust, but this is not that workshop, so I would just assume that you're comfortable if I don't, explain everything. So yeah, in the first function, so capitalize string, we would take 2 arguments. So there would be a value, which is a string, and a output, which is a mutable string. Again, like very Rust thing, I'm not going to explain that. So after that, we just say like, hey, if it's not, empty, just capitalize the first character. This is a very straightforward thing to do. Again, like if you're familiar with Rust, it should be, kind of easy to understand. But even if not, it should be similar to Python enough that you can get the feeling of what it's doing. So after that, you see that we have some, the hash. So it's like, oh, it's not a comment. I mean, I know in Python it's a comment, but in Rust, that means that I'm having a macro here. Again, like I'm not going to explain macro now. Just imagine it's kind of, this line is kind of like a decorative thing in Rust. So it's a hash, and then you see that it's like Polars expression. So Polars underscore expr, and then there are some parameters inside. So that thing, if you have done PyO3 before, you will never see it because obviously it's from the Polar side of thing. It just means that you can use it. So for example, here we see output type equals to string. We are using it to define what would be the output type of the Polar series. Here we're just taking a a string, and then the output would be a string. So that's why output type is string. But without it, then we'll come into some issue because Polars will not know what is the type of that specific Polar series, right? So so we need that. So that's the unique thing in this workshop compared to a PyO3 workshop. And then yeah, so in that we'll do the actual thing that we'll call the capitalized string function that we have built before, and then just say that, hey, we have a string chunk. So the string chunks basically, you can imagine it's like a Polar series that got input, right? So again, if you want to know more, you can look into the documentation and see what are these things. But basically, it means that it's outputting a series that is the type is the string. Yeah, so far, is it okay, or you get very lost when you look at the Rust code? Yes?
The CI input at the position of 0, so is it the first column here is meant in this instruction? That's line 14.
Yes.
Yeah.
It's mainly because, yeah, so it's, how do I put it? Because input can be multiple columns. Okay. So this is just unwrapping it. Okay. Yeah. Yeah. It's okay. Okay. So, okay, question.
The apply into string amortized, that's a Rust functionality in the string object, or?
Okay, apply into a string motorized. That is actually provided by the Polars extension. Apply is provided by PyO3 Polars. It's from Polars. Yeah, Polars, we have the use Polars prelude and style, right? So that's from there. It's from Polars because so when you unwrap the output, so inside is a special type of things that's defined by Polars. So yeah, if you want to see what that is, it will be appearing in the Polars documentation there. Yeah. Yeah, so basically it will take, you can see that it's taking the function that we defined before, and then it will just apply that to CA, because CA is the series. So it's not just a string. So it's a special type of things that is, defined by polars. Yeah. Okay, any questions, or it's very confusing? Okay, I hope you found it interesting. I found it interesting. So, yeah, so after that, we would, okay, so we have written that. So that is the expression.rs. So if you have some experience writing PyO3 or any Rust library, that you know that you have to have a lib.rs, right? So because it's kind of like main in Python, that like so like compiler will know that the lib.rs is basically the entry point when it's looking at what's going on and like what to, how to put things together. So expression.rs, which is the script that I just described, is basically like, I don't want to write everything in lib.rs. I want to write in a separate, file. So you write the expression.rs. That just makes things more neat. Technically, you don't have to have expression.rs. You can just put all of those functions inside lib.rs. But when your extension grow bigger, it'll get messy very quickly. So this is the recommended way to do things. Yeah, so, yes.
So there's already a lib.rs in this folder. Should I override it with the new content?
Yes, overwrite with the new content.
Okay,
because when you do Maturin init, it will give you a lib.rs, but that one is just an example when you just do, compiled a Python library. So it's not going to work with Polars, that one, so replace it with the new one. Yeah, so the new one, you see the first line is using mod expressions, so that is kind of like importing that expression.rs. Again, like, that's kind of like, Python will only have import, but, in Rust it's a little bit different. But anyway, so you can imagine it's import for now, not to confuse yourself. And then later you see like you have PyModule, well, because it's a standard for PyO3. So PyO3 will recognize that and pack it into a Python module. And then you see that like now we have underscore internal. Because we have named it something dot internal, so like we have internal. And then you see that like in the module we'll add, so now it's not adding anything, it's basically just adding the version. Right now here, yeah, so it's just like, so it's adding version, which is like, it's just saying like what version we're using right now. So now it's not actually doing anything in this script. So we haven't added yet here. Also, we have the global underscore allocator. So that is also unique to Polars. Yeah, so it's, because like we don't add the method directly like we do in, for example, if you have done PyO3 before, right, we'll add it there. So it's like, why m.add is not, like we are not adding the capitalized that we have defined in the expression. Why we're not doing that? Because Polars works a little bit differently, so that's why we have to use the global allocator there to do the allocation. So yeah, so that's why it's defined there. So we are not like, we are not adding it directly in the module. Like we are not doing m.add capitalized there. It will come back afterward. You'll see like where it goes after. So. So that's the Rust side of things. So it's like Rust code going through and through. But like I said before, because we use .internal, so we still have to do something on the Python side to make it work. Otherwise, it won't work. So, so now we create a underscore init.py. And then inside it, we will put those like code inside. We will like, when we have the plugin, so it will be put, so if you follow the instructions, it will be put the init.py will be put within your plugin because, that's where, when you import your extension, that's where it will get processed. So now we go to Python code. In the Python code, we would have very standard thing like the path and the type checking. That's not Polar, so I won't explain that. So here you see that we have. So Polars also provide these things for you to plug and play, right? So there's like also the Polars.plugins. You can like import the register plugin function, so that provide a functionality for you to put your Polars plugin into Polars and work with Polars. So here we would define another capitalized. This time it appears in Python. So now it will become a Python function that you could use, or actually it's a Polar. Technically, it's a Polar expression because it will return a Polar expression. So it would provide you the Polar expression that you will be using. So it's there. You also have to define the plugin path, but I don't think you'll change it very often. It's just like the parents of the file, because you're putting it in init.py, and then of course the path is the parents of the file. So yeah, just make sure you have that line. So you see that in there, so in the Python, df capitalized, you see that like we are returning a Polar expression. So here, we are returning the capitalized that we have defined in Rust. So you see in Rust, we didn't add it as a module for PyO3 to add to the extension. Instead, we added to an allocator. And here is actually where the allocator will be able to find the capitalized and make it into a Polar expression that when you call it from Polar side of things, it will see the capitalized function and use it. Does it make sense? I know it's very convoluted. Any questions? Yes.
Where did we introduce the expressions actually in the lib.rs? I mean, did we publish this capitalized somewhere in this lib.rs? Shouldn't we do this somewhere?
So you can imagine now is becoming a Polar expression. So what this Python function does is to create. So basically, this is like a wrapper, wrapping the Rust capitalized, and then it's wrapped up as a Polar expression. So imagine PyO3 is doing this behind the scene, right? PyO3 is wrapping your function. So if you add the hash Py function, PyO3 is wrapping it as a Python function like that you can call from your Python library, right? Here, you are just doing it yourself. And then like, oh, can you wrap it into a Polar expression? So Polars can call it and use it directly, like
so just by inserting this mod expressions in the lib.rs, that was enough to...
Yeah, that function take care of it. That's provided by Polars, and Polars will take all these things, and then it will, because we have added it to the allocator, right? So probably it will find it in the allocator, and then find, oh, that's the capitalized that you have,
Yeah, that's what I mean. Where did we add it to the allocator?
In the Rust code. If you scroll back up in the Rust code, you see like global allocator, static allocator. So that we created the allocator there.
Yeah, but we didn't add anything to this allocator.
We haven't added anything. Why does it? I think it would do a search on the capitalized. The name need to be matching.
Okay.
Yeah. But again, like that's my speculation. I haven't looked into what that function actually do. I may be wrong, but that's my speculation. Yeah. So, go through all the gauntlets. Now, we will build and test the plugin. Finally, we'll see if it works. So, if you do Maturin develop, again, like if you have used PyO3 before, you should be familiar with that. So you do Maturin develop, and then it will create the plugin for you, supposedly, if everything works. If you see any like compilation error and stuff, then like please let me know. Something wrong with Rust. We'll debug it. Yes?
Yeah, so I figured on the dependencies we're missing Polars arrow. Yeah.
Oh, we're missing pi arrows. In Python or in Rust?
In Rust.
In Rust? Oh, that may be something new.
Just adding a very loose, just like on the dependencies you see Polars equals, so. Yeah, okay. So I've just checking the code, right? On the cargo.toml, below Polars, you see the dependencies Polars equals version star. We just need to add below that Polars arrow.
Polars arrow, that may be something new. Like, for me, before I don't need it, but yeah. Yeah, again, like it works on my computer. Why is yeah, but again, like edit. Let me double check why it's, sorry, I pressed the wrong thing. Let me see.
And there is one more thing.
Okay.
Yes, on lib.rs, exactly. We also need to add a module called PyModule methods. With that, it compiles.
Are you using the same version that I'm using?
Probably not.
Yeah, like, again, like, I have checked it last week that like I'm using the version like that and it just worked, and that's new to me. But I mean, like you're going on an adventure, why not just like follow along and add those and see if it works? Yeah. Yeah, okay. Other than that,
I was just adding that in theory, Polars does not depend on arrow or pi arrow. So I just commented on that,
yeah,
which
so
made me confused.
yeah, it's like, I mean, that's new to me because it works last week without that. And if you use the same version, technically, I think it should work. Right? No, it doesn't.
Hello. I run the command to create the package, and it generates a couple of a target folder and also a file called internal.evi3.so, something like that. Well, it creates some files. My question is that these files need to be also, committed and published on a repository, or because maybe it could, generate more files and how do you manage that?
Right now, I will only have a init.py in the, so the file you mentioned, right, and the underscore internal.abi3.so,
yeah,
that is actually what has been compiled.
Okay.
So it will sit in your, for me, the name is Polars plugin 101, right? Polars plugin 101 inside, there should be the init file, the Python file that we just talked about, and that internal file, right?
Yeah.
So anything that is under the Polars plugin 101, so those two files, that is actually your extension. So if you want to give it to someone else to use, you can send it to them, you can put it on GitHub release on GitHub, or you can put it on PyPI. So that's actually where your plugin is. That's your plugin. That's
okay.
Yeah. So like you can like keep it away. So you can keep it away from this GitHub repo because this repo is for building it, right? But if you want to release it, that's your release.
Ah, okay, got it.
Yeah.
All right, thank you.
Yeah. Any more questions?
For some strange reason, it doesn't create this compiled file in the folder.
It doesn't create, then you would have a compilation error, right?
No, it's the compilation is just fine.
Double check your cargo.toml to see if the settings are correct. Okay, so it doesn't create that file. Is the name matching? Is the name of the library matching the folder name?
So the name like Polars tutorial PyCon 25 should be the same as, okay. It is not the same, but it doesn't create the folder on its own.
So, okay, so there's a few things that need to match. So first of all, so your cargo.toml file, it should say the name of the package. It could be my package, right? Let's assume it's my package. So if you go to pyproject.toml, under the to.maturin setting, the module name should be mypackage._internal. So those two need to match. When those two match, and also the project name needs to be like my package as well in pyproject.toml. So those three matches, then it should have the folder name as my package when you compiled it. So it would be like under my package, you would have the _internal dot. Yeah. Yeah, it's tricky. You have to match the names because otherwise it won't find it.
Okay, I will try that out. Thank you.
Yeah, I can come and have a look later. I think now we have, we have like reached almost 45 minutes. Do we want a break? And then you can just try it out yourself right now, and I can also walk around and do troubleshooting. Does it work for everyone? Okay, let's take a short break. You can try, so you have done Maturin, develop, and now you can just like test the plugin yourself. So, because I assume you can write Python code and Polar, so I will let you test it yourself. And I will just walk around if you have questions. Anyone want me to come over and have a look? Yes. Yes. Mm-hmm. Uh-huh. Mm-hmm. Okay. So for the remote attendee, so after like walking around, we have some issues. People have issues with the versions. So one way of making sure the versions work is to download the cargo.log from the repo. Then it will help, because sometimes, there's some versions that doesn't like the other version, and we have all been there. So like for Python, we have requirements.txt, but for Rust, it will be cargo.log. So if you get the cargo.log from the repo, so if you have like version issues, just get the cargo.log from the repo. And it seems like the projector is working. Let me try, for some reason. Yeah, so let's see. Let's see if it works. Yay, it works, I think. Woohoo! Finally. Good, then the next speaker have a projector to use. Okay, so right, let's go back to where we were. I'm sorry about that. Let's go back to README. And why is it so small? Why is it so small? What happened to you? Okay, let me open it again. Right, okay, yeah. Okay. Oh, by the way, if you're curious about what I'm using right now, this is not PyCharm, this is Rust Rover. But in Rust Rover, you can install a Python plugin, so you can also run Python there. Yay. If you want to know more about it, talk to us in the booth. I'm not going to say it here. Yeah. Okay, so where were we? Okay, so hopefully most of you go through all the gauntlet and have already registered and like run it and then, try in Polars and it works. Yeah, now I'm lost, wait. Okay, I think we are, okay, we have go through this, we have go through this, step 4, the heading is a bit wrong, I would fix it afterwards, but congratulations, you have created your first Polar plugin. I hope you test it out and it works. So now, we can go through the now it's kind of working, so we can do more about it. We don't want to capitalize all the time. We want to do something else. So now we're working with numbers. Well, a lot of us work with numbers in data frames. I think that's quite standard. The example here is very simple, just converting Celsius to Fahrenheit is a formula. You can find it online. Of course, I don't remember it by heart. So can we created that, right? Can we created a expression just converting the Celsius to Fahrenheit? So again, if you, so I know some of you are more like, I already know that you're confident and have done it like PyO3 or Rust before. So maybe you can do it yourself, right? You don't have to follow along. You can just, go to all the things that we already have, create another function, changing, adding the formula there, calculate. One thing to pay attention is the output type need to match. So far, the output type we have used is string. If we are dealing with like temperatures, we want, well, I mean, you can use integer, but Fahrenheit will have, decimals a lot of times. So maybe use a float because, you don't have to worry about changing it back to integer after the calculation of like division, whatever. So yeah, like for those of you who are new to Rust, you can't just use flow. You have to decide whether it's a flow 64, a flow 32, or flow 12? No, 16. Yeah, or flow 16. So yeah, if in doubt, just use flow 64. It may not be the most memory saving one, but we're just doing an exercise here, so just use flow 64. Yeah. So again, I don't want to explain it in so much detail because I want you to try it yourself. So again, if you are confident enough, don't look at it. Try to, just follow the formula and make one yourself, and make it work, and then try it out in Polars. So maybe I would give you a little bit of time to try it out yourself. Yeah, if you are stuck, then you can just copy and paste the code and read it. So that's just we are stepping outside of our comfort zone and trying different input and output type thing. Yeah. So maybe I will give you 2 or 3 minutes. Again, ask questions at any time. I'm happy to take questions. And then after that, we will have another exercise to find the larger value. So that's a little bit different. I will go over the difference in a bit when you're done with the Fahrenheit, temperature conversion thingy. Yes.
There's a spelling mistake in the Rust function name. The H is missing in Fahrenheit. In the
A PR is welcome.
Yeah.
Thank you.
I just wanted to point that out.
Yeah, thank you. Oh, by the way, I'm terrible with spelling, so if you found anything wrong, a PR is welcome. Huh? If you want to, it's up to you. I'm not saying you have to, but if you have time, you can do it. You don't have to do it now. You can do it after, or you got a bit, the talk. Maybe you go later. It's boring, and then you want to do something else. You can do this. Okay, so after that conversion, we are going to we are going to do something a little bit different. So for the next exercise, getting the larger value, we would have 2 inputs, right? So because we need to compare 2 values, we will have 2 columns instead of just 1 column. So how we can do it is, again, remember we have the input square bracket 0. That was a very good question to kind of lead to this place, because input is actually multiple columns. So you may ask, why do polars know that I'm taking multiple columns? Well, we would define it in the Python side when we create a polar expression. But on the Rust side of things, it's still it's still input there, and then when you have multiple columns, the first column, it will be the first one in there. The second one will be the second one. So we just use the square bracket to get them back. So that's kind of answer the question right now here. You can see input 0, input 1. Okay, so go back to the question of how polars know that this polar expression is taking 2 columns instead of 1. Is in the Python side. We defined it here, args. We define what is going to be the input for the polar expression. So you see we have expression 1, expression 2. So we actually take 2 columns from polars, or series, column, what do you call them? But anyway, so you take 2 inputs, basically, here. It defines it. It will take 2 inputs. And then they would be packaged together. And when it go to the Rust side of things, it will be this type. It will be N series type. Is it too small? It's too small for me, so I would zoom in. So it will be so this is actually a sequence of series. So it's multiple. So that's why we have to unpack it here with so the inputs is actually multiple, so we have to unpack it. Does it make sense? Questions? Oh, good. So if you're good, then challenge yourself and take a you can now take extra challenge. Now you can make the largest expression and take an arbitrary amount of inputs and can you take arbitrary amount instead of just 2? Can we? Yeah, also I have a possible solution there. Your solution may not be exactly the same, but there is a suggestion. If you are oh, I need some hints, you can have a look there. So I'll give you some time to challenge yourself. I won't spoil it for you just yet. So now you understand how to take multiple input. Can you take arbitrary amount of input? I'll take the silence as challenge accepted, so I will just pause here for a bit. Oh, questions, okay.
I have a bit of a conceptual question.
Yes.
So polars has a max between columns function sort of built in, right? So the question is where are the limitations in what exists in polars already, and when do we really see speed up? Well, if I'm deciding here's what I want to do on my columns, when should I decide, okay, it's worth the investment to sit down and write the Rust code versus try to build something out of, polars, existing operations or Python primitives, et cetera?
Right. Rule of thumbs, if it's provided by polars, use it. Because that would be, if you can bid it, you probably want to contribute to polars or become a maintainer of polars. So if Polar give it to you out of the box, use it. So the next thing is whether you want to write a Python function, use.apply, so you define the custom thing on the Python side, or go through all this thing. I found it interesting, but you would be like, I don't have time for that. I'm working. So again, like, if I were you, right, you're working, you just want it to work, do it in Python first. If you do it in Python, you're not happy with the speed, because if you put it in production, your manager said, like, hey, this is not good, this is too slow, we need it faster, come up with something that is faster. This could be your solution. So I know not all of you may come into this situation very often. Usually it only happens when you're handling a large amount of data, or you need to have it done really quick because you're doing something real time. Then this is a tool for you. But again, like, if you're just prototyping something, it may not worth your time to, like, write Rust code and all this stuff, right? So I think if you use something very often, maybe it's worth the time. Like, if you use it all the time, and then if you just like go through this once, and then it will just make everything in your team faster, then yeah, maybe it's worth. Again, it's the trade-off between the developer's time and the execution time. So you make the choice. Yeah. Yeah.
Thanks.
I just performed a little experiment just right now with this whole capitalization thing. So with a Rust internal function that we wrote ourselves, and with a Python given function, it's called string.title. And I start to be faster with the Rust function consistently with 1 million string samples. If it's below that, if it's 100,000 string samples, it's roughly equal in speed. But it starts to become substantially faster with 1 million samples and more. I don't know if that helps, but just random experiment right now.
Yes, I think that's a very good good point, that like maybe you should do some profiling, like what you just did. Do some experiment, see like where it's going to, like how large is large, right? This you have to switch over. So again, I trust your developer skills that you will be able to make some good choices. Good. Do we want to look at the solution, or you have already seen it and it's not exciting anymore? Okay, let's have a quick look. Because I forgot what I did. Oh, it doesn't work because it's not on GitHub. It's here. Okay. So where do I put it? Largest. Yeah, largest is, actually it's not as common, because I forgot. I wrote this a long time ago, so I was like, okay. Right, let's see if I can zoom in. I can't zoom in here. Okay, so I will just tell you what I did. So on the Rust side of things, I just, for outputs, instead of calling 0, 1, 2, I can just loop it over, right? So I can just process them one by one. And then again, like inside the loop, I think I don't have to explain the logic. You probably already have an idea, like hold the largest and then replace it. And on the Python side of things, when you take an arbitrary amount, so instead of, remember, like we put expression 1, expression 2, and then put it in a square bracket, right? So actually, args basically just take a list. So I just don't unpack and pack it again. I just say like, args, just take it, and then Rust will take care of it. So again, like you can have a look yourself if you want to know. So if you have figured it out yourself, congratulations, you are very smart and smarter than me. So good. Right. So next. So we have already, done the numeric calculation. We can take multiple inputs. What about different data types, right? So again, if you are developing for, let's say, the whole team, because this function is used a lot in the whole team, but it's not always the same type. For example, it could be an integer, it could be a float. So I want to create something that even I put in an integer or put in a float, it will still work, because the logic could be the same, like finding the larger number or the largest number, that, it should be the same, right? The logic, like integer or float, you know, so why not just have one and then the whole team can use it? So here in this exercise, we will try to do that, right? How do we handle multiple data types so it will work on different data types? There need to be a little bit of work here because you can see, okay, so you can see that instead of having it static, like here, output type equals to int64, we have to write a function in Rust to determine what output type is, what input type it should be, or output type it should be, because if, like, okay, unless you wanted to always output float, I think if you like, you know, if you're working in the integer kind of space, you want to output the integer when it come back, then you'll probably, yeah, you want it to be dynamic. So to make it dynamic, you need to have a Rust function to determine it and then put it as output type function instead of output type, so it's not static, so it's like dynamic, so it's determined. So how can you determine it? Well, like for example here, if the inputs are integer, I want it to output as integer, I don't want to change the type. So yeah, I would just like, oh, okay, it's the same as the input field. So if the first, so yeah, this is, again, like the first column, if you have multiple columns, then, you know, the second doesn't count here. But you can also make some decision yourself to like, oh, if the first one and the second one is integer, then it's integer. If not, then it's float. You can also do that. But here is just a simple example. You can improve it yourself. So yeah, I just cloned the type of the first one. So if it's an int 32, it will be int 32. If it's the int 64, it will be int 64. Blah, blah. So it would be just the same. If it's a string, it would probably be a string, but then like the whole thing would break down because I am assuming that it is a number. Anyway, so the code now, so we can dynamically determine the output type. What about the actual execution of the logic, right? So it's a bit complicated because yeah, you can see that it's a bit complicated. So for each type, we will have a different chunk of code to handle it because the type that we're using in Rust are different, and Rust is not like Python. You can just, you know, don't type it if you don't feel like it. You have to type everything. So that's why we have to handle each different type in a different like code block here. But luckily, in Rust, you can use the match syntax. Well, now we can do it in Python too, but match is used a lot in Rust for this reason. So yeah, again, I'm just matching the outputs, the first column. You can also write some logic that what happened if the second one doesn't match. You can say like, oh, maybe an error will come out, or you can make some logic like decision there. So yeah, it works like this. And of course, if you have like, you know, the second input, like, I mean, the input second one is not matching the first one, it will break down here. You'll probably have an error somewhere. I should have written the error somewhere. But yeah, it will just break down here for now. And also, oh, you see that like, you know, in Rust it's so complicated because there's a different function for float and for integer. So that's why it looks a little bit different between the integer and the float here. It's not just the type is different. Yeah, so if anything that doesn't match this, then it would just stop and it would just break down. It just say like, give the error message like, it doesn't work. It needs to match, you know. So if you pass in a string, basically it would just go through this branch and say like, you know, Polar, stop. Something's wrong. Like Polar's bail. Like something's wrong. Just, you know, yeah, give an error message and stop. This is what is going to happen. Again, like you can expand the logic. You can also like maybe have other way of handling it. This is just an example. Yeah. So if you want to do the extra challenge right now, I will give you a few minutes to digest this code. And also, if you want to do the extra challenge, can you also convert the largest in that kind of, you know, powerful way that you can take multiple data types? Okay. So, what time does this workshop end? Quarter past, okay. We have like 15 minutes. Yeah. So maybe we have time to look a little bit of the advance. Again, like this material I've prepared is a lot. So we won't be able to cover, I'm not aiming to cover all of them today. I will just go as far as we could, and then the rest you can do it at home, and then, you know, you can contact me if you have questions or, you know, whatever. So, but we have 15 minutes, so yeah, ask questions. Again, like take a few moments to digest the last exercise, and then we'll move on after. Okay, so let's look at string, because string, if you are familiar with Rust, string is weird in Rust. So it's extra weird if you're not just having a string, but like, for example, you have a column of string type. It would be super weird. So let's have a look into this. So what we're doing here, we are now basically like combining the string together with a space. So yeah, that's what we do here. I know it's very silly, but the point is we learn how to work with string. So you will see that, yeah, oh, we need the whole thing here. Why we need to iter? And then, well, it's because, again, like here S is a column of input, so the column of strings. So here you can see that we have to go through all of the strings inside and then do something there. So yeah, so that's the main difference here. Also, you have to collect it and put it back into a string chunked. So yeah. And then of course, like, you have to also do some cloning, because otherwise the lifetime is not long enough for that string to survive this code chunk. So yeah, it looks super complicated only because there are a lot of limitations in Rust about working with strings, and like all this lifetime thing and borrow. So I think it's worth putting an example here. So if you are working with strings, then you have something you can start with. Yeah, so the clone is there because, you know, the lifetime thing. And then, yeah, also we have to do the iter because we have to handle them one by one, and then, you know, do this logic here. Does it make sense to you? Any questions so far? Take a moment, deep breath. Yeah. Any questions? No? Okay. I know you're tired. I understand. It's at the end. We only have like 15 minutes left. So, but we'll just go over it again. Like, you can look at it at home, try the challenges, and yeah. So the string is more or less the same. Is, you know, on the Python side of things, it's just like, but what we are doing here is to make element-wise force, because yeah, because what happened before is that we would work on them one by one. Oh, sorry, I know why it's like super weird here, because what we are doing here is to I wish I could show you. Can I show you? So what it does is that, for example, I have a column of A, B, C, D, E, F, G, H, I, J, K, right? So this function, what it will do is that it will make it A, B, C, D, E, F, G, H, I, J, K into A, A, B, A, B, C, A, B, C, D, E. Do you understand? So, or I should run the code, which is like, let's see if I can do it. Like, I should have something here. Let's see. Okay. Yeah, I know it's super small, but like I will see if I can zoom it in afterwards. Okay. So it's something like this. Let's see if I can make it bigger. Can I make it bigger? No, plus, command plus doesn't work here. But what you can see is like, so I have the name John Smith, and then the next is John Smith and Mary Johnson. So I add, I'm not just adding these two together, but I'm also adding the previous one, right? So that's why that's what the code there is trying to do. So if I close this one and go back there, this is what it's trying to do. It's like, it's scanning it from top to bottom. So that's why it needs to do this. So it's like, need to handle each one by one and then add it there. So it's like, and that's why its element-wise need to be forced, because now so this Rust function, this Rust expression is processing the whole column before we are doing element-wise. If we recall, so its element-wise is true, right? So far, all our things this is true. So when you see this, where's the Rust thing? Let me look at one of these. So when you see this is actually handle them like element-wise, so each element. Now I want the whole column. So that's why, I don't know why we jumped to that. Did I skip something? I don't know. Okay. I don't know what happened. Okay. So so this is processing the whole column all together in this Rust function instead of processing just the cell. Is it clear now? No. So the inputs here, input 0 here, this one is a whole column. The inputs there, the inputs here, the inputs there, the inputs up there here, what is the equivalent? So the input here, this input, is just one. Yeah. How to switch between the two is actually on the Python side here. Is element-wise true or false? Okay. So that's the difference here, and that's why it's so complicated, but you may need that for some reason. So that's what this is doing. Again, like have another look again. We have 10 minutes, so I will go over this one. So this one is like, what if I want to take a user input, right? So in the example before, you see that we have the space. So it's like A space B space C, I link it up like that. But what if I want to be like the name one, right? So I want to have a new line, so each name is in a new line, or I want to be a comma, whatever. I want to take a user input. So this exercise is saying like how I can take a user input, and now you see that like why we need to import this library, because we are trying to use the serialize here. Do I have time to explain this? So, derive. So again, like if you're not familiar with Rust, in Rust there are something that like the compiler will check whether. So let's talk about in Python analogy. In Python, imagine in Python when you run the Python code, there's a checker to check whether that method exists, right? So it's kind of like that in Rust. So the compiler will check whether it has that define for it. if it hasn't, then things break down. So this is basically saying like, oh, just derive that for me, so Rust will check that there's a deserialized in this struct, in this object, so it won't break down, basically. Again, like, look at the Rust book if you're not sure. I don't think I can have enough time to explain that, so sorry about that. But again, like, yeah, look at, this is a Rust thing. So, right, so now, what we are doing is we will take an extra keyword argument, which we have defined here. So what we are doing is that, like, we would have a user-defined, no, we have a, you would take an input from the user. So the, so it's called separation, okay? So, or maybe it's like, let's do it backward. Let's see, like, when we are using it here, when we are using it here, we can define the argument. Did I write it here? Where did I write it? Where's last? Maybe I didn't put it here, so sorry about that. So yeah, what that does, I'm so concerned about the time. Okay, so what that does is that it will take an extra keyword argument here. So you see in the Python side, I would say like, oh, not just take the argument, which is like the columns in your data frame, but you can also have user input to give an extra argument there called SEP. So you can SEP equals to, let's say, a tab. Then it was separated by tab because we have it added here. So the way to add it is that we have to have a struct that have the deserialized derived. Yeah? Yeah? Is it confusing or questions? Yeah, this is the last thing, so I just want to wrap it up. But I know I do a very bad job explaining it. 5 minutes left, so I want you to ask questions. Yeah. So basically, what this does is like you can have an input. Like for example, like I really want to show you how it works, but I need to see my old code, which I kind of forgot. Okay. Yeah, like multiple columns. Okay. Where I. Oh, here. Oh, okay. Yeah. So you can add the separate, like here, so you can like, this is the, I know it's super small. Okay, I'll spell it out for you. So inside here, I have I use the column string, which is the one I defined there, which is the polar expression, my custom polar expression. I would take the names, which is like the names of column, and I can define a separator, which is a comma and a space. So, yeah. So then this work because I have defined it in my extension that I can take a user input, a extra user input there. So it doesn't need to be a column. Because it's silly, right? You'd be like, oh, separation, and then comma. So you can just input it like that. Yeah, I hope it makes sense. And 5 minutes left. Questions? Or I can like do a promotion because on my repo, you already have the link to. If you go to my GitHub, you will see there's other PyO3 workshop. If you're not familiar with PyO3, you can also do this workshop yourself. Again, available on my GitHub. You can go there and do the PyO3 workshops, and I can give you a sneak peek of what it is. So new project. No, open. Okay. Oops, sorry, I should not touch the mic. Okay, sorry about that. 1 sec. Recent project. So I have like PyO3 101 and PyO3 102. I think 101 is probably what you want to do if you want to like, you know, understand the polar extension a little bit better. So it's similar format. Again, it's on my GitHub. And yeah, so it's like this. There's lots of exercise. But this will have more explanation of what, like, if you're not familiar with Rust, not familiar with PyO3, this is a very good point to start. I know today may be a little bit more challenging for you because you have no experience for that. But then, like, don't look at that. So yeah, like, if you're not familiar with PyO3, then this is a good place to start because then it will just like explain a little bit more. It will also explain the Rust kind of thing a little bit more. So if you're not familiar with it, I think this is a very good place to start. And then after that, you go back to your Polar extension workshop, then you would have a better understanding of why we are doing it that way, right? Rust is so weird. It's like, yeah, but then you fall in love with it and, think that Rust is not that weird. And I love the quirkiness of Rust. Yeah. If no questions, then I will just let you go and enjoy the lunch.
Well, Cheuk, thank you very much.